Guess what? Proofs again. So we're going to be doing similar triangle proofs now. So we got to know what are our ways to prove triangles similar is we use AA, SAS, and SSS, except side, side, side doesn't mean all sides are congruent. It means their sides are proportional. Same with SAS. The sides are proportional, not congruent. Different. So here we go. Let's do each of these examples. It's telling us MN is parallel to JL. That could be our given. MN parallel to JL given. And then we know, based on that, these are going to be congruent. So angle KMN is congruent to angle KJL because of corresponding angles. See how it comes back? Good. Same thing with the other one. KNM is congruent to KLJ because of corresponding angles. We could have also said angle K is equal to angle congruent to angle K because of reflexive property, but I chose this. So we have AA, we have our two angles. So JKL is similar to triangle MKN because of AA similarity. There we go. There's one. Next. What do they give us? Angle EAB. Oh, wrong one. EAB is congruent. Nope. I jumped ahead. EAB and DCB are right angles. So we know that is our given. EAB and DCB are right angles. That is our given. All right, which means the measure of these equal 90 degrees. The reason we know that is the definition of right angle. So, since those are 90 degrees and they're each equal to 90 degrees, we could say EAB is congruent to DCB because of, you could either say substitution or transitive property. I'm going to say transitive property of equality. All right, so there we go. There's one. Okay. All right. Technically, we have to say they're equal. Sorry. They're equal, and then we say they're congruent by congruence property. Definition of congruence. Def of congruence. All right, so we have one angles, and then we can say these are congruent. So angle ABE is congruent to angle CBD because of vertical angles. And then we got it. Triangles EAB and triangles DCB are similar because of AA. There we go. Hopefully you guys remember this stuff. And here we go. Number 3. WY bisects XYZ, which means that must be equal to that. So, so I'm going to just say that is a given, which means angle XYW must be congruent to ZYV because of definition of angle bisector. A bisector means it cuts in half. All right, so that's a good start. Let's change colors here. It also says XY to YZ is proportional. So let's put that as our given. to WY equals VY. That means they're proportional. XY to YZ. So this, I'm not going to say they're equal, but how do we say this? Similar, proportional to ZY, just as VY is to WY. Yeah, so we're good. This means triangles WXY is similar to triangle VZY because of SAS similarity. Okay, between, let's write this a little bit nicer so you guys can understand it. So it's saying this is similar, I don't know how to write this, similar to this, and it's saying this, VY, is similar to WY. Therefore, we have a side angle side, side angle side, therefore SAS similarity, okay? These are going to equal some scale factor. Let's say it is 2. And since the XY is bigger on top and the ZY and VY is smaller on the bottom, that means it's going to get bigger than 1. So it could be 2. Very well could be 2. Okay, so let's try another one. Number 4. PR is parallel to ST. It's going to be our first. It's going to be a given. PR is parallel to ST. That means we're going to have some transversals probably that are going to help us. And then we know that UT, let's change color. UT is equal to 2 PQs. Let's not do that yet. Let's see if we can work anything with a red first. So can we find anything with a red? Is there a transversal that will help us? Ding, ding, ding. Yes. This and this. What are those? So we have angle RPQ is congruent to angle, what's happening? STU based on alternate interior angles. Okay, so now I think we got everything we can from that. Now let's go to UT equals 2PQ and ST equals 2PR. Those are our givens. Okay, so, oh man, this is going to be a proportion. So can't we say UT over PQ equals 2? Just as we can say ST over PR equals 2. That would be division property of equality. And now we have a proportion. UT, similar, just as it's similar to PQ, as ST and PR. So again, we have an SAS here. But first we got to show they are the same. So it kind of is given, but we got to put it. PQ is equal to ST over PR. Oops. PR by, we could say transitive or substitution. This time we'll say substitution. Substitution. And now we have enough. So now we can say PQR is similar to TUS because of SAS similarity. Okay. Ooh, this is a long one. I like it. All right, so let's separate these. Let's think what they want. So we have a given. Let's do them all at once. The measure of ACB, that is 110. CDE, that's 40. And measure of B is 30. That's all we know. We're trying to prove they are congruent or similar triangles. So, first thing we could say is the measure of ACB plus the measure of A plus the measure of B equals 180 degrees because of triangle sum theorem. And then we could use substitution and say this is 110 degrees. A we don't know. B we know is 30. That's substitution. Substitution. And then we solve for A by, we gotta do it step by step, I think. So we get 140 plus measure of A equals 180. So that is going to be just, I don't know, simplify, or you can say combine like terms. And then we get measure of A equals 40. That's going to be subtraction property of equality. And then, since measure of A is 40, ooh, this is good. Therefore, we can say the measure of A equals the measure of CDE because of substitution property. Substitution property. Right? Measure of A equals 40. CDE equals 40. Therefore, they equal each other. You could also write transitive property. That's fine. Okay, so we know those are equal. And then we can say they're congruent because of def of congruence. And one more. We can also say angle ACB is congruent to angle DCE because of reflexive property. So it's basically like saying the measure of angle C is congruent to measure of angle C. And there we go. We have two angles. So we can say triangle ACB is similar to triangle DCE. Ooh, that was bad. Based on A similarity. Nice. All right, how many do we got? 3, 4. Oh my God. I'm just gonna do the odds now. Too much. This is a big one. Number 7. Here we go. Oh, number 6 was easier. Number 6 is easy. Let's just do it. Given. Therefore, triangle LMN is similar to triangle PQR because of SSS similarity. Therefore, angle N is congruent to angle R. So we used to say CPCTC when the triangles were congruent. Now we say CASTC. CA, which means corresponding angles of similar triangles are congruent. It used to be corresponding parts of congruent triangles are congruent. Now it's corresponding angles of similar triangles are congruent. Casticat. Okay, that's another one you gotta know. This one, number 7. All right. I think this is gonna be the last one I do. Yep, last one I'm doing. All right, RS is congruent to ST. Okay. So we got ourselves a an isosceles triangle. And UW is congruent to VW. And we know R is congruent to U. I mean, we could have said that anyways because we knew that the sides are, if it's not, two sides are congruent, that means it's an isosceles triangle anyway. All right, so, all right, put that here. That's a given. Therefore, triangles RST and triangles UWV are isosceles. Based on definition of isosceles triangles. Okay, which means, and it also tells us, we don't even actually have to write this, angle R is congruent to angle T, and angle U is congruent to angle V, since base angles, base angles of isos triangles are congruent. Okay. So. Also, we know angle R. Oh, they didn't tell us that. I just assumed. They did tell us this. Those are congruent. That helps us. So now we can say angle R is congruent to angle U. That's a given. And angle T is congruent to angle U because of transitive property. Because if R is congruent to U and R is congruent to T, therefore T is congruent to U. And we can also say, therefore T is congruent to V because of also transitive property. And now we have AA. That's nice. So we can say RST is congruent. Wrong chapter is similar to UWV because of AA similarity. And since the triangles are similar, that means their sides are proportional. And we can write that by saying corresponding sides, we can't say parts, of similar triangles are proportionate. CSSTP. Ooh, almost better to write it. There you go. There's number 7. Number 8, quick and easy again. Given. And we know angle DEC is congruent to FEG because of vertical angles. Therefore, since DE goes with FE and GE goes with CE, we got ourselves an SAS. DEC triangle is similar to FEG because of SAS similarity. Okay, last one. Ooh, long one. Beast. Okay, so tells us this. That's our given. It also tells us that, so that means, let's just go from there. That means the measure of Rn equals 90 degrees. We got to do this. It's a pain in the butt, but we got to do it. Qn equals 90 degrees based on definition of right triangles. And then we can say MRN is equal to PQN because of substitution. You could also say transitive property for this one. And then we can say they are congruent because of definition of congruence. Definition of congruence says if things are equal, then they are also congruent. All right, so there's that. And then let's go to our next information. It says Q is the midpoint of NR. That is a given. Q is the midpoint of NR, which means NQ must be congruent or equal to QR, which means NQ must be equal to QR based on definition of midpoint. We just use the givens and follow every information we can get from that. All right, and that also means that, NQ. If I added an NQ to both sides, this is a tricky one. I like it. So what if I, MR equals, I gotta prove proportionality. So here we go. You see how it has MR equals 2PQ? MR equals 2PQ. So we have to do something with NQ and NR somehow. So let's see if we can get it working here. So let's add an NQ. So if we added an NQ to both sides, that would be addition property. Addition property of equality. I'll just write addition property. Okay, and then we can combine like terms. Equals QR plus NQ. That's just simplifying or combining like terms. And then we can say NQ plus NQ equals NR. NQ plus NQ. NQ plus NQ equals NR. How do we know that? Since NQ equals QR, we can say 2NQ equals QR plus NQ. So 2NQ equals QR, so this is equal to NR. So NR, remember, NR equals NQ plus QR. We can see that from up here based on the segment addition property. So that's good to know. And then we go from there. We say 2NQ equals NR. 2NQ equals NR. 2NQ equals NR. That's just simplifying. Or we could say substitution. Substitute here. I would say that's just simplifying. Okay, and then if we divide by NQ, we get 2 equals NR over NQ based on division property. Okay, so we take our last given now. There we go. I'm going to take that back and change colors here. Let's go to blue. All right, that is a given. And then we find our, by dividing again, that's going to be the proportional part. PQ equals 2. That is going to be division property. And then we can say MR over PQ equals NR over NQ based on transitive property or substitution. You can put either. And since we have MR goes with PQ and NR goes with NQ, this whole thing goes with NQ, we could say what? We could say SAS similarities, because don't we have an angle? Yeah, it tells us this. It tells us these are both right, so it's between those. So we get our final answer. MRN is similar to PQN because of SAS. That's it. All right, see you guys.